Hi everyone and welcome to the third video on the entity relationship model. In this video we will look at some extended ER schemas or diagrams where we will look at real world business situations and how we can use ER concepts to create these diagrams. And we'll also see how once we create an ER schema or an ER diagram, how we can use this to actually document some of the deeper meaning that's in the data requirements. So let's get started with the first example. So the first example we look at is one that could be used, for example, in homeland security type applications, where we are looking at, let's say, the airlines for passenger flights, let's say in the United States. So we want to build a database for that. And here we are building a data model or a data schema for the data requirements. So the first thing we're going to look at is the entity set. So you can see, for example, here we have all the airlines. So every time you do an entity set, you want to be very clear what's in the box. So here, for example, an example data might be Southwest Airlines, would be one entry. Um, American Airlines would be another entry, and so on. The next box we can look at is the planes box. And every time we do boxes like this, we want to think about, are we putting plane models or are we putting actual physical planes in the box? So for example, the Boeing 737 is a model. And if this was just plain models, then the Boeing 737 would be one entry. But let's say there's 100 Boeing 737s in the United States. Then if this was actual physical planes, there would be 100 entries in this box. So we need to be very careful and clear on what we are putting. Now in this case, take a moment to think about whether it's going to be plane models or planes. Pause the video and take a moment to think. After you're done, you can see the answer. So the answer is actually based on this cardinality here. It's one plane for each airline. I'm sorry, for each plane, there's one and only one airline, which means that there are physical planes in this box. So if there's 100 Boeing 737s, there will be 100 entries for that in this box. Okay, the next thing we want to look at is this weak-entity set called passenger rows. And this would be like, for example, row 23 or row 22. So there'll be 1,000 or 10,000 or 100,000 different row 22s, probably one for each plane. And so in order to identify a particular row within our system, we need the plane ID and we also need the row ID. And so both of those taken together will identify the row. So for example, it might be plane. So here's an example. Plane 23DE, row 3. So this would be an example of a row on plane 23DE, whichever plane that is. Similarly to rows, we have a weak entity set called seats, which turns out to be a weak entity set of rows. So an example of a seat would be like seat A or seat B or seat C. And so of course there'll be like millions of A's, and that's not enough to identify the seat. You also need to know the row, and a row of course is also identified by the plane ID. So an example of a seat would be plane 23DE, row 3A. Right? So that would be an example of a seat. So this is an example of cascading entity sets. Now you can look at the flights box next. And here again you want to think about, let's say the Southwest flight 322 that flies, let's say, every day. And so if this was flight types, then there would be one entry for Southwest flight 322. But there is another thing, which is the instance of the flight, the actual event. And those would be happening every day. So there would be thousands of flight 322 events. So are we capturing the event here or are we capturing just the flight? So take a moment to think about that and see. So if you look at this, in this case, there's in this case, you're actually capturing the event. So it's a much more granular data out here. So every event is being captured, not just the flight information, but every event, every flight event. That's in this box. So there'll be thousands of flight 322s in this box, each one with its own ID. So it won't be flight 322, it'll be its own barcoded ID or some sort of a random string that would be used to generate the flight ID. It's not going to be flight 322 because there'll be thousands of them that are flight 322. So that would be an extra attribute here. Okay, let's take a look at how the flights are linked. So you can see a link between flights and rows. So for each flight event, there is a link to a row. And why are we linking it to a row? Because we want to capture if there was an air marshal sitting during that flight and if there was an infant sitting during that flight in that row. So that's best captured as a linked property between the row and the flight. You can see that for each flight there's one and only one plane, which further uh, uh, gives evidence that the flights in this box are flight events. Okay, the next thing we want to look at is passengers. So all the passengers are in this box. And we want to link the passenger to the seat for a particular flight. So here a three-way diamond is actually appropriate. And you'll notice out here that we have attributes of the diamond like what the passenger listened to during that flight on that seat, what kind of drinks they had, what condition they left the seat in. So these are all linked attributes. They're not relevant on a passenger because the passenger can be on many different flights, many different seats. They're not relevant to the seat because the seat would have many different passengers across flights. They're certainly not relevant on the flight because uh, on the same flight there'll be many passengers on many seats. So this set of attributes here is only relevant on this diamond, which is a three-way diamond. So take a moment to study all the different linked and intrinsic properties that are here and see how much of the data is being captured. Let's go on to. Okay, in this example, we're looking at a standard brick and mortar store. In this case, we've used the example of a camera store, but it could actually be any brick and mortar store where they sell certain types of products. In this case, it would be cameras. So an example of a product type would be, let's say, a particular camera model like a Canon 5D, let's say, or a Canon 1D, or a Canon 7D. So these would all be different models of cameras. And then there's the concept of product items, which is again instances of the product types. So if the store has 100 Canon 5Ds, then there's going to be 100 entries in this box. And if they have 20 Canon 1Ds, there's going to be 20 entries in this box. So you can see that this box contains the physical inventory. And this box contains what you would call the product catalog. Okay, now there's two basic transactions, or not transactions, but processes that happen in a store like this. So the first is the sales process where the products are sold to customers, and the second is the ordering process where products are ordered from suppliers through purchase orders. So let's take a look at the sales one first because that's more intuitive. So in the sales side, you can see there's a box called sales which stores all the sales events in the box. So each sale event is a sale transaction basically, and it's linked to a customer, as you can see here. Make sure you can see the cardinalities. So this one here, for example, would be for each sale one customer. And then the sale is also linked to the product items that are on the sale. So each physical camera could be linked to 0 to 1 sales at most. Out here we're assuming that if it comes back as a return, it's given a different barcode as an item, so it becomes a new item. We're not keeping track of it as an old item, right? So that's basically it for the sales side. It's pretty straightforward. Now let's take a look on the supply side, where it's a little bit more complicated. So not only do suppliers supply stuff based on purchase orders, but they also maintain price lists. So this would be an example of capturing the data needed for the price list. You're linking the supplier to the product type, and you have these extra attributes here that would make up the price list. And so for each uh, product type, depending on the supplier, you'll have a different price that they will be willing to supply it at. So that would be the price list. Now, every time the store wants to order like some items from the suppliers, they will make up a purchase order, which is equivalent to the sale, but on the purchase side. So it's a transaction. And the purchase order is going to be linked to one supplier, just like say it is linked to one customer. And then on the purchase order, you're going to link it to different product types when you send the order, because you haven't received the product items yet. And there you're going to specify how much you want. So for example, on one purchase order, you may say that you want 5 Canon 1Ds at a price of, let's say, $2,500 each. And you want maybe 10 Canon 5Ds at a price of $1,600 each, right? So that would be one purchase order. Now, when the supplier ships the actual physical items and they come into the store, they're going to be given barcodes, maybe little stickers with barcodes on them. But you're also going to then want to link those back to the purchase order, because you want to keep track of your physical inventory. Who was the person who supplied it, which supplier, and who was the person who bought it. This gives you a competitive advantage of the store versus simply saying that customer Joe walked in and bought a Canon 5D. You want to be able to say customer Joe walked in and bought this particular 5D that was supplied to me by supplier Sam, right? So that gives you the ability then to track if there's problems in your inventory, exactly where the causes are, right? If there's returns that come in that are uh, uh, which have damaged equipment, then you can trace it back to the customer if you are keeping track of things at the physical inventory level. So this is an example of a brick and mortar diagram that would work for almost any product type, not just cameras. Of course, the attributes would be much more. This is a simple example to learn, but you would have many more examples. You may have subclasses of product types and so on. So what do we conclude from this? So the first thing we conclude is that the ER model is a rich semantic data model. And in this case, we use two examples whose natural language requirements are well known to us. But it's possible to have a document that contains natural language requirements for a different domain or a different business setting, which may not be familiar to us. And then the skill that we want to develop is how to draw the ER schema or the EER schema for such a specification. Now, once you've drawn the ER schema, then it actually becomes a big source of documentation for some of the deeper meaning in these requirements. Not all of the deeper meaning, but some of the deeper meaning. And then once you've captured it in the ER model, then actually the design of your database will capture some of this deeper meaning and help you in your data quality. So as a fun activity, you can try to ask yourself exactly what kind of information has been captured in these two ER diagrams that we just saw. For example, let's say there's a business rule that an air marshal should be able to travel in the same row on the same plane on two different flights or three different flights. Is that allowable in our data model? So similarly, you can test out different business rules and see which of those we can capture and which of those we cannot capture in the ER diagram. Hope you enjoyed this video. We'll see you for the next one.